Okay, hello guys, this is 2014 number 3, and I cut and paste over here. I have a little workspace here going on here. Okay, so I'm gonna do all of this actually. So let's go ahead and start with letter A. I hope you guys have already read the problem, and this is probably the most important key part right here. G of x equals to this definite integral, -3 to x of f of t. So diving into letter A, they want us to find g of 3. Now, g of 3 would simply be just integration from -3 to 3 of f of t dt. Right? I'm just replacing that x with a 3. Now, I want to clarify something between this and the whole area under the curve thing. This right here, that's a straight up integration. Now, when you're doing straight integration, you can get negative values. If you are asked to represent this area as an integration, then you have to remember to do the whole upper minus lower, right minus left to ensure that you don't get negative values. So if you're going to do an area represented by integration, you're not going to get negative values, right? And you have to make sure about that. I'm going to reiterate again, doing an upper minus lower, right minus left each time you do it. But again, back to this guy, that's a straight integration. You can get negative values. So looking at your graph here, this right here is, this is -3, and over here is x equals 3, right? I'm going to zoom in a little bit more. So essentially, the problem is asking you for this region here, plus this region here, plus, and I'm going to divide this right here from 3, plus this region here. Now you notice that this region from 2 to 3, that's underneath the x-axis. So this is going to give you a quote-unquote negative area. Again, we're doing straight integration. You can get negative values. So as you're figuring out these problems, and I'm going to use just straight area, right? I have area of my first two triangles. These are going to be positive area, and right here on the bottom right here, that's going to be a negative area. So you're going to have a negative value assigned to that because I'm just doing an integration. I'm not doing area represented by an integration. Okay? So area of triangle, 1/2 base times height. The area of the first triangle, I'm going to mark it right here. This area, I believe, is 6. That's from -3 to 0. And I have another one represented from 0 to 2. This is a value of 4. And the value, the area for 2 to 3, which is underneath again, that's a value of -1. So I'm going to figure this out using, I just did that using area of a triangle. So g of 3 is simply going to be 6 plus 4 minus 1, which will give you value of 9. Okay, that's letter A. Letter B. On the open intervals contained from -5 to 4 is a graph of g both increasing. Oh, I'm sorry. On what open intervals? Contained from -5 to 4, the entire graph essentially, is a graph of g both increasing and concave down. Give reason for your answers. Okay. If I'm looking for increasing concave down, first of all, increasing uh, is derivative, right? We're talking about slope. And concave down is second derivative, right? So I want to find, I'm going to do this. On the graph of g, I want actually g prime of x. Now g prime of x, remember, g of x is the integration from -3 to x of f of t. Using fundamental theorem of calculus, you're just going to simply get f of x if I find the derivative of both sides, and I'm talking about these equations here. If I did derivatives of both sides, I'm simply going to get g prime of x on the left and then f of x on the right. Okay? So my derivative of g is my function f of x, which means the graph that I'm looking at right here, that's my derivative of g. So you can put a little note here on the graph this is the same thing as g prime, right? This whole graph is my slope of g, which is kind of nice, right? So if I'm looking for where on g is it both increasing and concave down, so first of all, increasing means where is this graph above the x-axis, right? Everything above this x-axis, I have a positive g graph, increasing. Anything below the x-axis, that would be my negative slope of my g graph, right? Because remember, this graph that we're looking at is g prime. That's the slope of g, okay? Now, in terms of concave down, just to give you a quick representation, my slope is decreasing, right? And this I drew as a negative slope, but you can also do a concave down like this, right? In both cases, my slope is increasing. In my first case here, my slope I should say, my slope here is negative and my slope here is positive. But in both cases, my slope is decreasing, okay? It is decreasing. So on your graph, you're looking for when my slope goes like this, decreasing, and here's another one decreasing. So I essentially just marked both of those area where it's decreasing. It is decreasing from here, and it's decreasing from here. Now remember, we have to include where it's increasing, so I got to stay above the x-axis at the same time. So instead of doing this, this is decreasing, this is decreasing. Well, this right here is all negative. So I have this value here, and I have this value here. So essentially from -5 to -3, and from 0 to 2 is where my graph of g is increasing and concave down at the same time. Okay, so I'm going to write that out. So I have what open intervals, so I have starting from, open interval from -5 to -3, right? And from 0 to 2, g is increasing and concave down. And of course, they probably want you to give reason. Yep. Okay, so I'm going to write because g prime, which is f, I'm showing that I understand that g prime is just f, right? Is what is I guess a positive above the x-axis, right? Positive and decreasing in these intervals. Okay. All right. Letter C. I'll do it over here. The function h is defined by h of x equals to g of x over 5x. Find h prime of 3. Okay, so I need to first find h prime of x. Now this is going to be just a quotient rule, right? Low D high minus high D low over low low. So low, which is going to be 5x, times D high, which is g prime of x, times 1, minus high, which is gx, times D low, well D low isn't that just 5, over low low, which is going to be 5x quantity squared, which is going to be 25x squared, right? And if I want h prime of 3, well, I'm just going to substitute 3 in for all my x's and then solve, right? So it looks like I get 15 times g prime of 3 minus g of 3 times 5 over 25 times 3 squared. Not too bad, except we got to find g prime of 3. I think this is the key for this part here is, do you know what g prime of 3 is? And do you know what g of 3 is? Well, g of 3 we found in problem number 8, right? It's right here. It's 9. Okay, so that I know. G prime of 3, that's the slope at 3, right? Now, the slope of 3, if I input, I'm going to do a little side note here, g prime of 3 would simply be, remember, g prime of 3, remember, g prime is just f of x, so this is essentially just f of 3, the value of f of 3 on my graph, right? So if I look at my graph, let's see, f of 3, let me go to my graph here, f of 3, okay, so here is 3, f of 3 looks like right here, oops, right here, this guy right here, which is negative 2, that's your f of 3, right? So f of 3, which is g prime of 3, equals to negative 2, right? So inputting that all into here, you're going to get an answer of, I believe, negative 1/3. Okay? Letter D. All right, let's go. Function p is defined. All right, so now introduce another function. P of x equals to f of x squared minus x. Find the slope of the line tangent to the graph of p at x equals negative 1. Okay, I don't need a whole equation of the line. I just need the slope at a certain point, right? So essentially, I'm looking for p prime of negative 1. All right. Well, if this is p of x, then p prime of x would be, okay, so f prime of the inside times the derivative of the inside, which is going to be, this is 2x minus 1. And then p prime of 1, well, I'm going to input negative 1 here, so that means I get f prime of 1 plus 1, which is 2, times 2 times negative 1 minus 1, I believe that's a negative 3. So I need f prime of 2. That's the slope of my f graph at 2, right? So where's 2? Right here. I'm going to mark it with this right there, right? And they want the slope at 2. So essentially, you need to find the slope of this line here, which I'm going to let me erase this purple here, and this right here. I need the slope of that highlighted mark, which I believe you can do rise over run. You're going to get a value of negative 2, I believe, right? So f prime of 2, the slope at 2, is negative 2. And we just multiply by negative 3, which will give us a value of 6. Okay? That's it for now, guys. See you next time.